Hello students, welcome to fourth lecture of terpenes and terpenoids. In this lecture we are going to discuss the chemistry of menthol. We will discuss the occurrence and uses, structure determination of menthol and synthesis of menthol. So first of all, let us see from where menthol we get. The major source of menthol is peppermint oil. From the leaves of menthol, we get the peppermint oil. Menthol is a white, solid crystalline compound. Menthol is having many applications. It is used as a local anesthetics. It is widely used to relieve minor throat irritation. It is used in pharmaceuticals, cosmetics, toothpaste, and toiletries. Now we discuss the structure determination of menthol. Structure determination of menthol was initiated in 1886. In those days, the chemists were not having a sophisticated instruments and therefore they will relying on the chemical methods of analysis. This chemical method of analysis is based on structure determination of elemental. The molecular formula, when carbon and hydrogen to be estimated, then molecular formula of menthol is found to be C10H20O. This molecular formula contains 10 carbon atoms. Therefore, it belongs to monoterpenoid class of terpenoid. And it contains 2 isoprene units joined head to tail linkage. So we get a broad idea just by counting the number of carbon atoms in molecular formula of menthol. The second information that we get from molecular formula is degree of unsaturation of the double bond and the double bond equivalents, and how many double bonds and how many rings are nothing but the degree of unsaturation or the double bond equivalents. For molecular formula CXHYOZ, as we discussed earlier also, the double bond equivalent is calculated by x plus 1 minus y upon 2. So if we put these values here, then the double bond equivalent is found to be equal to 1. Now menthol is one double bond equivalent. It means that it may be a monocyclic compound or it may contains one double bond. So in subsequent investigations we have to find out the nature of unsaturation or nature of double bond equivalents. In preliminary experiments, it shows that the menthol is a saturated compound. Like bromination, hydrogenation reactions, it does not add bromine and hydrogen. It means that menthol is a saturated compound. Now let us find out the nature of oxygen. For this, menthol on acetylation with acetic anhydride with pyridine, it forms monoacetate derivative. Therefore, the menthol is an alcohol, and it also shows red color with steric ammonium nitrate, which shows that it contains a OH group. Yani menthol is an alcohol. On reaction with hydrogen iodide, now we determine the carbon skeleton. The menthol as well as the menthanone on reaction with hydrogen iodide give methane, and this reaction, when menthol reacts with hydrogen iodide, it forms paramethane, and on dehydration and dehydrogenation it forms paracymene. These both reactions shows that the presence of paramethane carbon skeleton in menthol, that is double bond equivalent equal to 1. This type of structure, paramethane, a cyclic ring with OH group. Now this we know that the alcohol is three types: primary, secondary, and tertiary. Then the question arises, what is its nature? And it can be analyzed by its oxidative study. How this oxidative degradation takes place? Now we see that oxidative degradation of menthol. When menthol oxidized with chromic acid, it forms menthone, and further oxidation with KMnO4, this second reaction, it forms a keto acid, ketomenthyllic acid, which on further oxidation it forms 3-methyl adipic acid and acetone. And this reaction proves the position of hydroxyl group in paramenthane, and therefore the structure of menthol is second this time. Now we take the oxidative degradation in detail. We take the first menthol. It reacts with chromic acid, oxidized with chromic acid. It forms menthenone, this compound, which on further oxidation the bond is break from here and forms ketomethylinic acid. And this ketomethylinic acid on further oxidation forms 3-methyl adipic acid, and this time bond is break from here. Isopropyl amide is breaking and form 3-methyl adipic acid plus acetone. And this is possible only when the structure of menthol is like this. The OH group is on the meta position from the methyl group, and if we take OH group at this position, the oxidation gives this product ketone, which on further oxidation forms this product, which on further oxidation forms this type of dicarboxylic acid, which does not support the menthol structure. Therefore, the oxidative degradation confirms and supports the menthol structure is this type. Now we take the summary of its whole investigations and confirm the structure of menthol, and from also the final confirmation is by synthesis of menthol. These both reactions we will take on the next lecture.